Okay, so in this section we're going to talk about logarithmic properties, and you might be wondering, well, why do we have logarithms? So from what we've done so far, it allows us to work with the exponents in algebraic terms. And so you'll see logarithms in science, engineering, calculus, things, along those lines. And so the nice thing about logarithms is there's just kind of a set of rules, and once we learn those, it doesn't really expand much beyond that. But those basic properties are going to be what you want to be familiar with. It allows us to work with exponents, and that becomes very useful. Okay, so we're going to start out with the basic properties. In total, there's about 8 logarithmic properties that we're going to cover. But these first two are just the basic properties. So what if you have log base b of 1? You know what? And we usually write it this way. Your book has been putting the parentheses, though, so they might write it like that. But let's say we don't know what that equals. A, say A. Well, you could convert that to exponential notation. B to some power of A equals 1. Now remember, this is a constant. The base of our logarithm is not a variable, but it's a constant. It could be 2 or 5. But if I'm going to get a 1, like say I had 5 to some power equals 1, or 2 to some power equals 1, that power has to be 0. A has to equal 0 then. So what that means then is the log base b, when the argument is 1, that's just going to equal 0. That is going to be true for all our log base b of 1. It won't matter what the base is. If the argument's 1, we're done. Okay, it equals 0. Okay, so similarly, let's say we have log base b of b. Say we don't know what that equals, and I'm going to write it down here. And again, you can put the parentheses. Usually it's not written that way in most textbooks, but it might be. Okay, so you have b. If I change it to exponential notation, you have b to some exponent a, and that's always going to equal b. Well, if I'm always going to get just the base here to be the base here, then doesn't a have to equal 1? Because I have to have that b to the first. If you look at it that way, we're saying this a has to match that exponent because they're equal to each other. And the bases are already the same. So when you have the base matching the argument, so the base here is matching the argument here, that's just going to equal 1. Now, I want this to be a nice clean property for you here, but that property is used a bit, okay? Both of these properties are. And those are the basic 2 properties. And like I said, there's 8 total properties. And so we're going to work on these basic, well, we did the basic 2, we'll do the inverse ones in the next video.